5-1, we're going to use properties of exponents. Okay, properties of exponents. There are a lot of them. That's why we're going to spend 2 days on it, because we've got to be familiar with them. Because from here on out, this chapter, chapter 7, chapter 9, a bunch of chapters use properties of exponents all the time. Okay? So we're going to have to be very familiar with these. We have 2, 4, 6, what do we have, 8? 2, 4, 6, 7. 7 properties of exponents. You have done some of these. I know you have, because I teach them to my 8th graders in pre-algebra. So you have done some of these in the past. We haven't hit some of them very hard, but we have hit others harder. So this should be a refresher for your memory, and hopefully it will come back to you pretty quickly. Okay? The first power property of exponents is the product of powers. Product of powers. If the bases are the same, a times a, okay, the bases are the same, to the m power times a to the n power, you add the powers. So if I have 5 cubed times 5 to the negative 1, I get 5 cubed plus negative 1, which gives me 5 squared, and then I would write my answer as 25, unless they say leave it in exponential form, okay? If they say leave it in exponential form, you'd leave it as 5 squared. If they don't say leave it in exponential form, you'll give me 25. You will not be plugging these into your calculator. You will be showing me the work by hand. Understood? I need to know that you know the rule. Once I know you know the rule, then I'll let you use your calculators. Okay? If I have a power of a power, that means a to an m power raised to an n power. Power to a power you multiply. Okay? You multiply the powers. So if I have 3 cubed squared, I have 3 to the 3rd times 2, which gives you 3 to the 6th, and then you would get 729. Once you get to this step, you can plug it into your calculator. Okay, I'm not going to make you do like 3 to the 1000th and tell me what it is. The power of a product. If I have a times b in parentheses to the m power, you can separate it out and say a to the m times b to the m. So if I have 2 times 3 to the 4th, I get 2 to the 4th times 3 to the 4th. So I do what 2 to the 4th is, I do what 3 to the 4th is, I multiply them together, you get 1,296. Okay? We do not like negative exponents. If you have a negative exponent, you simply give me the reciprocal of it. Okay? Meaning, if it says a to the negative m, I turn it into fraction form. 1 over a to the m. So if it says 7 to the negative 2, you give me 1 over 7 squared, which is 149. If it said 1 over 7 to the negative 2, you would flip it and give me 7 squared, which is 49. You always are doing opposite with it. You're flipping it. You're either putting it into a fraction with 1 on top, or you are putting it out of a fraction form into a whole number. You have to, we do not like negative exponents. They are not allowed. Okay? The easiest rule is the 0 exponent. Anything to the 0 power is 1. So b to the 0 is 1. 12 to the 0 is 1. Negative 22 to the 0 is 1. 1/12 to the 0 is 1. Okay? A over b to the 0 is 1. It's 1. Okay? The quotient power only works if the bases are the same again. If I have a to the m divided by a to the n, I get a to the m minus n. So 6 to the negative 3 over 6 to the negative 6, I get 6 to the negative 3 minus negative 6. Ding, ding, or blip, blip. And you get 6 to the 3rd, which equals 216. Remember, double negative is a positive. A blip, blip, a ding. I call them ding, dings. Mrs. McCain calls them blip, blips. My 8th grade teacher taught me to go ding, ding. So on our test, it would always be like ding, ding. Everybody would be making noise. Okay, so power of a quotient. If I have a over b to the m, once again, I can distribute that power to both parts. I can say a to the m divided by b to the m. So 4/7 squared, I get 4 squared over 7 squared, which is 16/49. If that is reducible, reduce it down. Okay. The other thing is scientific notation. Any of you in chemistry currently? Do you use scientific notation in there? I'm sure Mrs. Granger teaches scientific notation very well and very correctly. Very correctly, that's a weird statement. Okay. Scientific notation, remember we're going to have a constant times 10 to a power. The constant cannot be greater than 9, basically, right? I can't have a 10 there. So it's 10 to whatever power. If I move it, if I have a decimal and move it this way, is it negative or positive? So let's say I have 120, okay? I move the decimal this way, does it become negative or positive? It would be 1,
If
This
it
would
gets
be-
smaller, the number is
this would be 1.2 times 10 to the what? Second. If I have 0.120 and I move it this way, right? That would be a negative exponent, yes? Well, but you know what I'm saying. When I move it to the right, it's opposite of what you think, it's negative. If I move it to the left, it's,
If the number gets bigger,
Positive.
the exponent is small.
yep,
If the number gets smaller.
the exponent gets bigger. Has to be opposite of what it.
That's how I remember it.
Okay, so. Let us do this. What is 4 squared cubed? What would that look like, 4 squared cubed? What do I have to do? It equals what? 4 to the,
7, 6,
second times 3, good, which gives me 4 to the 6, which gives me what? This is where you're gonna need a calculator. This is where you- This is where you can use a calculator. Just so you know. What did it give you? 4,096. Now, here's the deal. It's gonna ask you, tell which property you used. What property is that? Because you're gonna have to get used to the names. Power and power. Okay, so on your homework, you're doing the same thing for me, okay? So I suggest you have the list listed out so that you can just look at it and get it in your mind. What happens on the next one? I have -8 times -8 cubed. What does that become? Can't do it on a calculator yet. There's a step before it. What is technically with this? What power? 1. So now you have -8 to the 1 plus 3, because these bases are the same, you add the exponents. So you get -8 to the, what is -8 to the 4th? Now you can use your calculator. And if you don't use parentheses, it's gonna come out negative. Would that be a correct answer? No, why? Because anything that's an even power is gonna come out to a positive. So -8 to the 4th should give you 4096. Now, what property is this?
Addition.
Product of powers. That's not even an option.
That's addition.
You probably should have a book out to see the properties. Product of powers, is that what you said? Okay, next you have this. 2/9 cubed, what do I do there? 2 cubed over 9 cubed. 2 cubed is easy, what is that? 8. What is 9 cubed? What's this? Is that reducible at all? I don't think it is, but. I don't think it is. Now, what property is that? I can't talk. Quotient of powers. Someone besides L should probably answer from now on. Okay, next you have 6 times 10 to the -4 over 9 times 10 to the 7th. Can you do anything there? And if you can, what do you do? What's that gonna look like? Do they have the same bases?
Yes.
What would be the same base?
10.
The 10, you think? Okay. You are correct. What do I do with the 6 and 9, though? What do you do with the 6 and 9?
Just divide it.
You do what in the class? Simplify. What goes into 6 and 9? So that would make this 2 over 3, right? Here you have 10 to the negative 4, 10 to the 7th. I know that if I do that, I subtract, correct? Okay, what is negative 4 and negative 7? Okay, so it would look like this. What's wrong with that? So what do I do with that exponent? Yes, you have to put it down below. So you're gonna end with an answer that looks like this. Now, we did several steps. Okay? What was the first one that we did to get to this 2 and 3 and that stuff right there? What? No, with the 10 up here, sorry. What's that called? What do you say? Quotient of powers. Quotient of powers. Okay? This step here is quotient of powers. What is this step, Elle? What's the next step? Yes. So we did 2 things. Okay, so on your homework you might have some that double down. You might have some that take 3 things. Okay, so name each step for me. A swarm of locusts may contain as many as 85 million locusts per square kilometer and cover an area of 1,200 square kilometers. About how many locusts are in such a swarm? What do you think I should do? What?
So the thing we just talked about, but
Not that.
the thing we just talked about.
You don't usually use it in math class, you use it in, yeah. What,
Word thing.
what type of class is that? What subject?
Science.
So what is that called? Science?
Oh, scientific
Scientific.
notation.
There we go. Scientific notation. So let's change 85 million into a scientific notation number and 1,200 into a scientific notation number, yes? Okay, 1,200 is easier. If I have 1,200, I simply move the decimal how many spots?
4. Oh,
3, okay? So I get 1.2 times 10 to the 3rd. That's what this changes to, yes? Okay, now 85 million. How many zeros are in million?
6.
6, good. So you have this, right? 85 million. So think about how many times this decimal changes. 1, 2, 3.
7 times.
7.
Okay, so I get 8.5 times 10 to the 7th. Okay, now, what do you think I do to multiply these together?
Multiply the 8.5 and the 1 and 2.
Beautiful, multiply the 8.5 and the 1.2. Let's start there, and you get 10.2, yes? We'll come and talk about that in a second. What do I do with the 10 to the 7th and 10 to the 3rd?
You just add them.
You just add them and you get 10 to the 10. Now, is this in scientific notation still?
Not yet.
No, what do I have to do with that number?
Move the decimal.
And if I move it once, what do I do?
You have to change that.
To the,
You have 3 things.
okay? So you have 1.02 times 10 to the 11th locusts in such a 1,200 square kilometers. It's a lot of locusts and kind of disgusting. Okay, so you have about, whew, that's a massive, massive swarm. Ugh, locusts, gross. Okay, let's do some where it involves letters and not numbers. Okay, if I have this, x to the negative 3 y cubed squared over x to the 5th y to the 6th. What do you think we should do first to start to simplify this? What do you think we need to do first? distribute this, the squared, okay? So I have a power to a power, what do I do?
Multiply.
Power to a power, multiply. So negative 3 and squared, what's that give me? So x to the negative 6, cubed and squared. And then I have it over top of this, yes? What's my next step from there?
Cancel out the
When I'm dividing, I don't cancel, what do I do? With the powers?
I'll just subtract.
You subtract, good. So I have x to the negative 6 minus 5, and I have y to the 6 minus 6, yes? What's negative 6 minus 5? X to the,
Negative one.
and 6 minus 6 is, which just gives me, anything to the 0 gives me,
So it cancels out.
well, yeah, that cancels out. What's wrong with this?
It can't be negative.
So what does my answer come out to be? 1,
Over
X
x 11.
and is that an option up there?
Yes.
And that is what the simplest form of that is. Take it step by step, okay? One step at a time to get to where we need to go. Cool? I'm gonna switch slides because that one's already on the board. I'm giving us lots of examples today, just so you know. Got this slide and one more, okay? So let's do some of these. Let's look at this one right here. Walk me through this first one, because this one should be the easiest of all of them. You have x to the negative 6 times x to the 5th times x cubed. They're all the same base, correct? What do I do with the powers? So what's negative 6 plus 5? And what's negative 1 plus 3? So you get x squared. Beautiful, x squared. Okay? And what power did I use when I did that? What property? Product of powers property. Now, next one. I'll draw this one up because it's a little bit more complicated. You have 7y squared z to the 5th times y to the negative 4th, right? Z to the negative 1. The 7 just stays, yes? Because there's no other number to multiply it with. What do I do when I have y squared times y to the negative 4th? You add them. What's 2 plus negative 4? So I get y to the negative 2. Z to the 5th, z to the negative 1, they're being multiplied, what do I do? So you get z to the 4th. What's still wrong with this?
Negative 2.
So what do I do with that y to the negative 2?
Move to y.
Move it to the bottom, so you have 7 z to the 4th up top, and you have y squared on the bottom. Now, what was this step when I combined all those, the first step we did?
Something quotient.
Something quotient, no quotient, we're not
Power.
dividing.
Something
Power
of
what?
power.
Product of powers. First step is product of powers, when you multiply it's called product. What was the second step when I moved that down to the bottom?
Negative 6.
Negative exponent, because all I did was deal with the negative. It is like proofs. Okay, now, look at the next one for me. You have s cubed over t to the negative 4, and you have them squared. What do I do first?
Distribute.
Distribute, so I get s to what power? 6 over t to what power? Okay, what's that called when I did that? Nope, I didn't divide yet. Power powers, because it was a power to a power, a power to a power. Now what do I do?
Quotient.
These aren't the same bases. It's negative, so what do I have to do to that?
Put it
You have to put it in the top. So you get s to the 6th, t to the 8th, and what's that
negative
called?
something.
It's just called negative, it's just called the negative property. Thank you for doing that. Last one, ready?
So if
Yes,
it's-
sir.
So if it's at the top, you put it at the bottom.
And if it's at the bottom, you put it at the top. It's that simple. Okay? X to the 4th, y to the negative 2, over x cubed, y to the 6th, and it's cubed. Okay? You can choose to do a couple different things in here, it doesn't matter what order you do it in, you'll still get the same answer, okay? So you and your neighbor can do it in different orders. What do we wanna do first here?
Distribute.
You wanna distribute, okay? So I get x to the fourth cubed, what does that make? If I have a power to a power, I multiply. What's y to the negative 2 cubed?
-6.
What is x cubed cubed?
9.
What is y to the 6 cubed?
18.
18. Okay, what was that called that we just did?
Power.
Power. Now what do I do? Now what do I do?
Put this -6 down.
Nope, not yet. Right now, they're being divided, which is called a quotient. What do I do when it's quotient of power?
Subtract.
Subtract. So x, 12 minus 9, right? And y to the negative 6 minus 18. What's 12 minus 9?
3,
So I get x cubed. What's negative 6 minus 18?
4, no, that's not right.
Negative 6 and negative 18 together.
-24.
Negative 24. Now what do you do from there?
You put the 24 on the bottom because they're negative.
So x cubed over y to the 24th. This part right here is called quotient of powers. What is this part called?
Negative x.
Negative exponent.
Let's go!
I'm trying to beat it into your mind. Okay, Betelgeuse is one of the stars found in the constellation
That's how you spell it?
Orion. What?
That's how you spell it.
Yeah.
The star, not the.
Not the movie, but that's the star, yes. Betelgeuse is one of the stars found in the constellation Orion. Its radius is about 1,500 times the radius of the sun. How many times as great as the sun's volume is Betelgeuse's volume? The question is, do you know the formula for volume of a sphere? Something like that, it's 4/3 pi r cubed.
Okay.
But you were on the right
I
track.
can do this,
Okay, so 4/3 pi r cubed. So volume equals 4/3 pi r cubed, because volume is always cubed. And we know what's the only number we have to work with? What's the only number we have to work with? 1,500. We want to compare them, right? We want to know how many times greater is it than the sun's. So it's 1,500 times greater, so we want to know what that is. So we're going to take 4/3 pi times 1,500 is the radius, right? 1,500 cubed, and we're going to divide it by 4/3 pi r cubed, yes? Because this represents Betelgeuse, this represents the sun. Betelgeuse over the sun. Okay, what happens there? What can I do? Can I cancel anything out, maybe? Oh wait, it's 1,500 times the radius of the sun, right? So it's not necessarily, it's times the radius of what the sun is, so it's like this. This should still have an R, because we don't know what the radius of the sun is. So look, I can cancel this out, right? And this out, and I'm left with 1,500 r cubed, yes? What do you do from there? Distribute the power? Okay, so what's 1,500 cubed? It's gonna be, yes, 3, 3, 7, 5, 1, 2, 3, 4, 5, 6 zeros, 2, 4, 6. And that's r cubed over r cubed. What happens with the r's?
Cancel.
They cancel, so my answer is,
3 million.
this would be billion, 3,375 million. Okay? So about 3.4 billion times as great as the sun's volume. Is that crazy or what? That's what you're doing tonight.